Welcome to Digital Lessons. In the last session, we have seen about simple circuits and how we can construct a simple circuit. It is very easy to construct a simple circuit by using a bulb, a battery and switch. Now let us see. Here we can find a battery, bulb and switch. By using them, we can glow the bulb. By pressing the key, the bulb will glow because current flowing through the circuit. We make a circuit with a bulb and cell. We make only one kind of circuit with a cell and a bulb, but we can make many types of circuits if we have more than one bulb or cell by connecting the components in different ways. That means not only one path, we will make the arrangement in different ways. Now first arrangement is called series circuit. In series circuit, electricity has only one path to flow. All the electrical components are connected in this path. Now let us see. Now here there are two bulbs. Each bulb to the positive terminal of the battery is connected to the wire and one end of the bulb. Other end of the bulb is connected to the other bulb. Now other end of the bulb is connected to the key. Now this other end of the key is connected to the negative terminal of the battery. By pressing the key, now current flows through the circuit. Now what happens here? Instead of one bulb, we are using two bulbs. This type of connection is called series connection. Now one bulb is connected to the other bulb. Series circuit. If any one of them is removed or is not functioning properly, the circuit will be incomplete. That means if we cut any bulb, the current will not pass through the circuit. It is a simple circuit. Now we will go for parallel circuit. A parallel circuit has more than one path for the flow of electricity. Each electrical component in the circuit is connected in a separate path through which electricity can flow. Here there are more than one path. Let us see in the diagram. Now here we can see two ends of the bulbs are connected to the positive terminal of the battery. Now other end of the bulb is connected to the switch through the negative terminal of the battery. That means one end of the bulbs are directly connected with the positive terminal. Other end of the bulb is directly connected to the negative terminal of the battery. That means here there are, see the path current, how current flows from positive terminal to the bulb, bulb to switch through negative terminal of the battery. Next see for the another bulb. Now from the positive terminal of the battery to the bulb, again to the negative terminal of the battery. There are two paths, not a single path. Two bulbs are connected in different paths. This type of arrangement is called parallel circuit. Now we will see about a simple circuit. Take a dry cell and a torch bulb. Connect the bulb to a cell using copper wires as shown in the figure. Now observe the intensity of the light. Now let us see. Here there is a bulb. It is connected to the battery. Now you see the intensity of the bulb. It is through one cell. Now circuit diagram for this already we learnt in the last class. That will be positive terminal of the battery connected to the bulb. Other end of the bulb is connected to the switch and switch is again connected to the negative terminal of the battery. Now here switch is closed. Therefore current is flowing in the circuit. Bulb is glowing. Now instead of one cell we will connect with two cells. Now observe the intensity of the light. Will the intensity increase or decrease? Yes, intensity of the bulb increased. If we keep three cells, again intensity of the bulb will be increased. This arrangement is nothing but series arrangement of cells. In this method, the positive terminal of the first cell and the negative terminal of the second cell are connected to the bulb. Is there any difference in the intensities of the bulb in the above case? Yes. First bulb we are having only one cell. Now there we are getting only 1.5 volts out of the cell. In the second case, we have used 2 cells, there we are getting 2 1.5 batteries, that means 2 into 1.5 volts, that is 3 volts. Here intensity of the bulb is increased. Now when does the bulb glow brighter? In the second case, when 2 cells are used, the bulb glow very brightly. Now you may use 3 or 4 cells in the same manner, that means now we can increase the intensity of the bulb by increasing the voltage in the series circuit. The bulb glows brighter and brighter, thus by connecting the cells in series we get a battery. The battery cells in the torch light are in series. Now let us see. Now here there are 3 cells in the torch. Now here see, first negative terminal of the first cell is connected to the negative terminal of the another cell with the positive terminal. Now here positive terminal of the second cell is connected with the negative terminal of the third cell. It is connected to the bulb. There is a switch. Whenever we on the switch, the bulb glows. In torchlight, the arrangement of cells will be in series. Now let us discuss cells in parallel. Take 3 dry cells and connect them as shown in the figure. Now let us see. Now here we are taking 3 cells. Now we are keeping all positive terminals on the top, 1, 2, 3. These are 3 positive terminals with the help of one wire. Now second, we are connecting negative terminal of the first cell is connected to the negative terminal of the second cell, again it is connected to the negative terminal of the third cell, and again it is connected to the bulb. Such arrangement is called parallel arrangement. Here we are connecting all the cells in parallel. Now it is the circuit diagram for that. All positive terminals are connected to one wire, all negative terminals are connected to another wire, that is connected to the bulb. Cells in parallel. All the positive terminals of the 3 cells are connected together and all the 3 negative terminals are connected together. Now these 3 positive and 3 negative terminals are connected to the bulb. Now let us see once again the diagram. All positive terminals are connected to the bulb, all negative terminals are connected to the bulb. In circuit diagram also, all positive terminals are connected with the help of one wire to the bulb, all negative terminals are connected with the help of one wire to the bulb. Now is there any difference in the intensity of the bulb glow compared to that in case of only one cell? Here we won't find any difference because the voltage is distributed equally to the all bulbs. There won't be any change in the intensity of the bulb, but the amount of the voltage divides between the cells and the bulbs glows for longer duration. Here we can increase the duration of the bulb by keeping more number of cells in this arrangement. When 2 or more batteries are placed in parallel, the voltage in the circuit is same as the individual battery. Now in the last case, in series connection of the cells, we have seen that voltage is increasing by increasing the number of cells, but here if you keep any number of cells, the voltage will be same, that will be 1.5 volt. The cells may be any number. Now we have seen for cells, now we will see for bulbs. Now here there are 3 bulbs. How they are connected? One end of the bulb is connected to the other end of the bulb. This end is connected to the other end of the bulb. These in turn connected with the positive and negative terminal of the batteries. This type of arrangement is called series connection in bulbs. Now see the circuit diagram. Here positive terminal of the battery connected to the switch. Through the switch it is connected to the bulb 1, one end of the bulb 1 connected to the end of the bulb 2, the end of the bulb 2 is connected to the bulb 3, the next end of the bulb 3 is in turn connected with the negative terminal of the battery. That means this type of arrangement is nothing but series arrangement in bulbs. Now, do all the bulbs light up? Yes, in series connection all bulbs light up, but do they glow equally bright? No, they won't go equally bright. First bulb will have more brightness when compared to the second bulb, and third bulb will have further reduction in the intensity. Why this is happening? Change the sequence of the bulb and observe the change. Now, you keep the bulbs 3 as 1 and 2 as 3 and 1 as 2. In this case, what happens? Even though if you change the bulbs, there won't be change in the intensity. The first bulb will from the circuit will have more brightness and the last bulb will have somewhat dimness. These bulbs do not glow equally bright when connected in series. Now, disconnect one of the 3 bulbs from the circuit. What do you observe? By disconnecting them, here you see 2 bulbs are connected. By disconnecting them, neither of the bulb glows. Here current is not flowing through the circuit because it is incomplete. There is only one path for the flow of electricity. Now, from the positive terminal there is a cut between 2 bulbs. From this no electricity passes. Therefore, this bulb won't glow and also this bulb also won't glow because the circuit is incomplete. Always in series connection of bulbs, this difficulty we will observe. In series connection of bulbs, if one bulb gets fused, all the other bulbs in the series will stop glowing. That means, if one bulb is disconnected, other bulbs also will stop glowing. It means that if one bulb is disconnected, the other bulbs do not glow. Bulbs in series. This can be observed in serial bulbs used in decorative items at the time of marriages and other festivals. This arrangement we will see in the decorative items of bulbs in our marriages and in our homes. Now, bulbs in parallel. Connect the 3 bulbs in parallel as shown in the figure. Let us see the connection. Here you see first end of the first bulb and one end of the second bulb. The end of the third bulb are connected to at one point to the single wire. That means, now the other end of the first bulb, second bulb and third bulb are connected to the at a single point. Now, here we can connect to the wire and to the battery. This type of arrangement is nothing but parallel arrangement in bulbs. Now, that is one end of the each of the 3 bulbs are connected to one wire. The other ends of the 3 bulbs are connected to other wire. These 2 wires are connected to a cell. All the 3 bulbs glow dimly. Yes, all the 3 bulbs will glow very dim when compared to series connection. Now, disconnect one of the bulbs. What happens? Can you predict? Yes, you are right. If one bulb is disconnected, other bulbs will keep on glowing. Why? Because there will be, just you observe here. Now, here how many paths are there? 2 paths are there. Now, first path is completed one. You have broken the wire in the second path. That means, here flow of electricity is stopped. This circuit is incomplete, but the other part, this circuit is complete. Therefore, electricity passes. If one bulb stops glowing also, other bulbs continues to glow. This is the advantage in bulbs in parallel. It means that if one bulb is disconnected, the other bulbs continue to glow. This can be observed in our household electric circuit. That means, if one switch fails also, another switch will work, another bulb will work in another room. Therefore, in all our household appliances, bulbs are connected in parallelly, not in series. What did you observe in our household connection? Always we will observe bulbs or other electrical appliances are connected in parallel. The lights and fans in our house are connected to the single main connection. We can switch any one of these on or off whenever we wish, others continue to work. If one stops glowing also, other will continue to work. So, all the components in our house are connected in parallel. Now, here we will see a video. Here you can see 3 bulbs. Now, the red wire is called phase, the black wire is called neutral wire, otherwise positive terminal, negative terminal we can call them. Now, in this circuit what is happening means we are connecting the 3 bulbs first in series. The black color wire is connected to the red color wire, that means negative terminal of this bulb is connected to the positive terminal of second bulb, and negative terminal of the second bulb is connected to the positive terminal of the third bulb. Now, you can see the connections here, it is a series connection. Now, here these 2 wires we are connecting to a battery. Now, let us see what happen if we connect to the battery. Now, this type of arrangement is called series connection in bulbs. Now, what is the advantage here? Now, we are connecting them to the cell. Now, here you can see the brightness also, whenever we connect them all the bulbs will glow equal brightness or not. Now, is there any change in the brightness of the bulbs? Now, let us observe carefully. Now, I am switching on the battery. Now, all bulbs are glowing. You see, first bulb is glowing, second bulb is somewhat dim, third bulb is somewhat still dim. Why? Because now current flowing from in this direction to this bulb, this to third bulb. Now, if at all I cut the bulb, you see all bulbs stop glowing. Now, this is the disadvantage in series connection. Here the flow of electricity is not there because there is a breakage. Here only one path, electricity is flowing through one path. Now, we connect the bulbs in parallelly. All positive terminals are connected to the at single point, all negative terminals are connected to the another single point. This black wire is called neutral wire and the red wire is called phase wire, generally positive terminal. Now, this is parallel arrangement of bulbs. Now, let them connect with wire. Now, we will connect them with wire and we will keep them to the battery. Now, observe the glow. Now, I am keeping cardboard here because heat will be more, therefore, I am keeping them on cardboard. Now, you see, whenever I switch on the bulbs, electricity flows in 3 different paths. So, first path, now all bulbs are glowing with equal brightness. This is the advantage in parallel connection of bulbs. Now, if I connect one of the path, others will continue to glow because their circuit is complete. It is path 1, path 2, path 3. Path 1 I have broken the wire, path 2 and path 3 are now closed. Therefore, circuit is complete and bulbs are glowing with equal brightness. Children, so far we have seen the parallel and series circuits. Now, we will see heating effects of electric current. Children, what happens whenever we light the bulb for more time? Yes, you are right, the bulb gets heated, and if we keep it for time, the bulb may diffuse. It is due to heating effect of electric current. The bulb becomes hot when you put it on for some time. Why do you think this happens? Yes, This happens because it is the filament of the bulb that heats up due to current flowing through it. Children, whenever current flows through a bulb, what happens? The filament in the bulbs gets heated up. Therefore, the filament here converts electric energy into light energy and heat energy. Therefore, the filament is the main source for heating in the bulb. You might have seen an electric iron, electric cooker and electric heater. Now, all these objects are used for heating purposes in our houses. Electric iron used for ironing our clothes, electric cooker used for cooking our food such as rice, and also electric heater which will be used for heating water during winter seasons. Now, all these items contain a coil in them. What is this coil? This coil is nothing but it is made up of a metal called nichrome, is an alloy of nickel and chromium. It can store heat for some time, and whenever electricity passes through it, the electric current here converts to heat energy. Now, this coil is called filament of the appliance. Now, children, what is the use of filament? Now, filament always gets heated due to electrical energy. Now, here you see it is an electric stove. Now, where is the filament here? A spring is there here. Whenever it is connected to electricity, it becomes red hot and emits heat energy for us. Thereby, we can cook our food very easily. Now, what is the filament made up of? The filament is made up of nichrome. It is an alloy. Now, look here, it is an iron box. In this iron box, now here there is a filament, it is called nichrome. Whenever these two plugs are connected with a wire, and the nichrome wire here converts into heat energy. Electrical energy is stored here for some time and it will be gets heated up. Now, the amount of heat produced in a wire depends on its material and length and thickness. More the thickness, the more heat it will radiate out. Thus, for different requirements, the wires of different materials, lengths and thickness are used. Now, in electric stove, we have seen here the length will be more and thickness will be very little, and whereas in iron box the thickness will be more and length is also more, and in electric heater length will be more and thickness will be very less, and thereby we will get heat energy depending upon the material and its length and also thickness. Now, the wires used for making electric circuits do not normally become hot. Normally, we will observe at our homes, whenever electricity passed, our copper wires do not get heated up because the current will flow very fastly through them. They cannot store the electricity for some time. On the other hand, the elements of some electrical appliances become so hot that they are easily visible. They becomes red hot and heat energy will be radiated out. Now, the filament of an electric bulb gets heated to such high temperature that it starts glowing and giving out light. Children, do you know which metal is used as a filament in electric bulb? Yes, the metal is tungsten. It gets heated up and its melting point is very high, even though in a bulb we will see a small spring like structure. Now you see here there is a small spring like structure, it is made up of a metal called tungsten. Therefore, now it will heated more. Due to its high melting point, tungsten will not melt that much easily, and here it will gets heated and light energy is radiated out. Now here you are seeing is another electrical device, it is electrical heater. Here also there will be a filament, and that will be on passage of electricity, heat energy will be supplied for us. Now look at these devices, children. Here there are some purposes with these electrical appliances. Now first we will read them and I will explain what to do with this next. An electric kettle, a lift in a building, a street lamp, a tube light, an exhaust fan, a rice cooker, a cassette player, an electric mixer, an electric oven, a water pump. All these are electrical devices. Now you have to categorize them according to their function. Now which devices are used for heating and which devices can give out light for us and which devices are helpful for movement. Now within 30 seconds you need to categorize them by making 3 columns in your notebook. Take some time, and what you have to do here, you need to divide 3 columns in your notebook. In first column you need to write used for light. In second column you need to write used for heat. In third column you should write used for movement. Now children, I think you have completed now. Let us see. Now here there is a tabular column which all items I have categorized here. Now the items from the above list which are used for light, just check your notebooks. Used for light are street lamp and tube light. Now used for heat, the electrical appliances which are used for heating purposes are electric kettle, a rice cooker, an electric oven. Next, the electrical appliances which are used for movement, a lift in a building, an exhaust fan, a cassette player, an electric mixer, a water pump. Now children, I think you have all done this correct. Now let us see what we have discussed in our session. Today's session we have discussed about the parallel and series connection of cells and parallel and series connection of bulbs. Now let us see what are the questions we can do as homework for today. Why does the bulb glow brighter and brighter when electric cells are connected in series? You have to write the reason. What is the reason for connecting electric bulbs in parallel in household electric circuit? What is the reason why you are connecting parallelly? Now if 4 cells of 1.5 volts are connected in series, what will be the total voltage? That means in series connection always voltage will be added. In parallel connection, this how many bulbs, many more cells may be, but the voltage remains same. Now to get the longest lifetime from the 2 cells, you would connect the cells in dash circuit, series circuit or parallel circuit, you have to mention. Now what is the effect on the brightness of the bulb by increasing the number of cells in parallel circuit? Now let us see, name some devices that run using heat effect of electric current. You have to name some devices that are used for heating purposes in your house. explain the heating effect of electric current with examples. Now children, in the next session we will go for the use of CFLF bulbs and how do we calculate the electricity bill in our house. Thank you.